How much rainwater can be harvested approximately? Before installing any rainwater harvesting system, it is always important to calculate the amount of rainwater that can be harvested from either roof or impervious ground surface. This is useful in order to determine the size of storage depending on the intended use of the harvested water. In order to calculate the amount of rainwater that can be harvested in a year, one needs to know the following. 1. The area of the surface on which water will be harvested from. For roofs, it is the flat area covering the roof, not the pitched areas. For hilly terrains, it is the flat surface incident area upon which the rain falls. 2. The ability of the surface to collect and release water. This is commonly called runoff coefficient. For example, iron roofs can easily collect and release rainwater into conveyance channels. In this case, the runoff coefficient for an iron roof is relatively high. However, earth surfaces absorb some of the rain, and hence the amount collected from such surfaces is always much lower. In this case, runoff coefficient for a normal earth surface is relatively low. 3. The average annual rainfall of the area. One can easily get the annual rainfall of the respective local area from the nearby meteorological office. 4. The average efficiency of the entire system, taking into account losses such as leakages and seepage. The simple formula for calculating the amount of rain that can be harvested in an effective area is Q is equal to S times S subscript RC times R times N, where Q is the amount of water that can be collected annually in liters, and S is the surface area where the rain is collected in meter squared, and S sub RC is the runoff coefficient. R is the annual rainfall in millimeter, and N is the system efficiency. For example, if the surface area of a roof is 80 meters squared with a runoff coefficient of 0.9, the annual rainfall of 700 mm and a rainwater harvesting system with efficiency of 95%, then the amount of rainwater that can be harvested is Q is equal to 80 times 0.9 times 700 times 0.95, which is equal to 47,880 liters.